velocity, then the net force necessary to cause this acceleration is equal to the mass of the object times the object's acceleration. This law can be written with a simple mathematic formula.
F is equal to ma.
What?
Force is equal mass times acceleration.
When two players collide, Newton's second law allows us to calculate what the final velocities of the two players will be. So, for example, a very large player striking a small player at rest will create a large velocity in the small player and maybe slow down a little bit himself.
For the smaller player to accelerate, a force must be applied to him. In this case, it's the body check from the larger player. Newton's third law of motion states that for every action there is an equal and opposite reaction, meaning that the larger player experiences a force from the smaller player pushing back on the bigger player, even if the smaller player is not trying to do so, slowing the bigger player down. Newton's third law of motion further explains that in this collision between the larger and smaller players, the combined total momentum of the two players remains conserved.
Even though one person is bigger than the other, it turns out remarkably that the amount of force that the big guy exerts on the little guy is exactly the same amount of force that the little guy exerts on the big guy.
Whenever one object applies a force to a second object, the second object applies the same force back to the first object. This can make checking collisions difficult, since any force applied to another player is applied back to you, something Matt Molson of the New York Islanders knows firsthand.
You see some guys that are, outweighed by maybe 30 pounds, couple inches, and they end up knocking the guy over just because of the balance they have.
To understand the real impact of these collisions on ice, look no further than these NHL superstars and the three laws of Sir Isaac Newton.